Here we go with number 2 in the ETA section. It says your position is latitude 4108.2 north, longitude 71 degrees 34.4 west at 15:23. That's our start time. You are turning 8.7 knots. What is your ETA at Shagwong Reef Buoy 7SR? So they really want to know what the time you will arrive. If you're traveling at 8.7 knots, you depart at 15:23. Okay, so here I am. Here's one spot. Here's the other. Okay, so I plot the two spots on the chart. Okay, I've already done that. Okay, and I'm going to have to, at some point, probably measure that distance, but let's not jump ahead of ourselves. So again, this is an ETA problem. So what is an ETA? An ETA is adding two numbers together. So we add our start time plus our travel time. Okay, if you add those two numbers together, you have an ETA. So the start time, did they give it to us in the problem? I suspect that they did. It was 15:23. And what do I always do with time when it's relevant to solving the problem? Okay, I change the minutes, not the hours, into tenths of an hour. So I've got 23 minutes. So if I take 23 and I divide them by 60, it gives me 0.38. So 15 hours and 23 minutes is the same thing as saying 15 hours and 38 tenths of an hour. Okay, 38 tenths of an hour. So if I find the travel time, I can complete the problem. So I've got to solve for travel time. So how do I solve for travel time? Well, first I like to draw a triangle because it's going to tell me how to do that. So I've got daylight savings time. Okay, and I'm going to write the formula for travel time. So it's distance divided by speed equals time. So I like to write those words. Distance divided by speed equals time, specifically travel time. So the distance, let's find the distance. How do I find the distance between those two places? I find them on the chart, I measure them, I mark them out on the chart, and then I take my dividers and I open them up to either the distance, if I can, okay, or if it's bigger than my dividers will open, I go to a nice round number like 5. Okay, so here's 5 miles. I'm going from this guy right here. Okay, and I'm going over here to Shagwong. And I'm going to put my parallel rule here, just so I end up in a fairly straight line. I'm just going to double check because there's a couple of Shagwongs and I'll make sure I'm using the right one. 7SR, I am. Okay, Shagwong 7SR is right there. And so I've got 5 miles, 10 miles, 15 miles, and just a little bit more. So 15 plus whatever this ends up being. Okay, so I check to see what that is. So it looks like it's 15.6. Okay, so my distance is 15.6 miles. So I'm going to write that down. 15.6, okay, divided by the speed. Well, again, they gave me the speed in the problem. Okay, the speed is 8.7 knots, 8.7. Okay, so I just do the math. 15.6 divided by 8.7 gives me a time of 1.79 hours. So I can plug that in, 1.79 hours, and then add them together. So I'm going to go 15.38 plus 1.79, simply adding my two times together, and that's 17.17. Okay, so can I tell somebody I'm going to arrive at 17 hours and 17 tenths of an hour or 17 sixtieths of an hour? No, I can't. I should probably change the tenths back into minutes. So my answer is going to be 17 hours and some number of minutes. Okay, again, that's not 17 minutes, that's 17/10 of an hour. So if I take the if I do 0.17, because that's what I have, 0.17, and I multiply by 60, I'll turn back into minutes. So equals 10.2 minutes. Okay, so I'll just leave that at 1710. Okay, that's 10.2 minutes. So my answer is 17 hours and 10 minutes, 1710. Remember that the 24-hour time clock is always written as a 4-digit number. Okay, so 17 hours and 10 minutes. So this is number 2. Let's see if we came up with an answer. There's 1711. I came up with 1710. They must have rounded up. I had 1710.2. So let's assume that they rounded up. Okay, so best answer for number 10 would be C.